Hello everyone. Today we will solve a resultant problem. Here the problem states figure 7 represents the sheave and a cable on the end of a derrick boom. Let theta equals 0 and find the resultant force on the sheave axle. Solve graphically and algebraically. What force on the boom is caused by the cable? So first let's draw a free body diagram for the axle. Here let's assume this point as axle, and then let's draw the vertical force here. Let's assume this is the vertical force, which is 4 tons, and then let's assume this portion of the force, which is in the theta degree angle with the horizontal component. But here the problem says theta equals 0, so the cable in that direction would be along the horizontal axis. So let's draw that. Here that is also 4 tons, and let's assume the angle between two forces is alpha. So the resultant would be along somewhere in the middle of the two forces. Let's mark it as R. Let's think the vertical force is F1 and the horizontal force is F2. And we know the resultant formula is R equals root over F1 square plus F2 square plus 2 F1 into F2 cos alpha. Since the both forces are in a right angle, because F1 is along the vertical axis and the F2 is along the horizontal axis, so the angle between them is 90 degree, and we know cos 90 equals 0. So the formula would be F1 square plus F2 square, and if we enter the values here, we get 4 square plus 4 square, and then the value would be 4 square plus 4 square, and then root over answer. Then we get 5.656. So we can write 5.66, and this is the resultant. Now we will have to find the angle of the resultant. Since the both components are in the horizontal and vertical axis, so we can write tan theta equals F1 by F2. Then we can write theta equals tan inverse, and then we can put the values in. So F1 equals 4 and F2 equals 4. Then we get theta equals tan inverse 1, because 4 divided by 4 equals 1. So we get 45 degree. So the angle between them, this would be theta, which is 45 degree. And if we assume the angle from the anti-clockwise from the first quadrant, then we get 270 minus 45 degree. So we get 225 degree, which would be from this portion to this portion. And if we think the last part of the math, here it says what force on the boom is caused by the cable. Here the resultant force and the angle of the resultant is applied on the axle. Because the axle is on the boom, so it would make an angle of, here we can see this is in 60 degree angle. So if we draw it here, we get a 60 degree plane. So this was 60 degree angle. So here we will also get a 60 degree angle. But here the resultant is making a 45 degree angle with the horizontal component. So the remaining part would be 60 minus 45, so we get 15 degree. So this portion would be 15 degree. So we can say that the resultant is making a 15 degree angle with the boom. If we calculate it from the first quadrant, then we get 180 plus 45, so we get 225 also. So that's it for this problem. So if you have any questions, feel free to ask. Thank you for watching.